Hello friends, good morning, good afternoon and good evening. Welcome back to my channel. So let's start with a new learning today. Today I'm going to talk to you on how to create the CAN database file. This is my agenda today. When we talk about the CAN database file, what is DBC file actually? Why it is needed? What are the different elements like messages, signals and value description? How you can extract the physical value from the raw CAN frame? What is the signal layouts, how it looks? What is the main window, and then we'll jump for the live demo. Here we will create the signal, value table, different attributes, can messages, nodes, and we will map all these elements to each other. We will take the live demo on that. So let's start with introduction. For example, if you record CAN bus data from a specific car or vehicle, the data you record will consist of set of CAN IDs and CAN data payloads. In order for this data to be useful for analysis or visualization, it must first be decoded. This process involves identification or identifying which CAN IDs contains which signal or parameters and how to extract them. So the DBC file contains this information in a standardized way, meaning that most CAN bus software and the API tools will allow you to easily decode a raw CAN bus data if you provide the database file or the DBC file as a secondary input to the software or the APS files. So this is the introduction. So DBC file describes the communication of a single CAN network. A text file, it is a text file that contains information for decoding raw CAN bus data to a physical value. So DBC file is a simple ASCII style text file that contains the information about the whole CAN frame and it functioning as a signal library basically. So let's jump for the need. What is need? Why it is needed? So before the database file was started creating earlier, there were a lot many difficulties faced. So difficulty faced earlier for a common way to manage identification and translation of a data. That was the biggest challenge earlier. And the DBC file helps to identify the data within the CAN frame by describing it. This is a very important find which clearly defines the need of database file. So primarily, it is used to analyze the CAN network. And again, it is used for measurement tasks on the CAN bus. So also, it is used for eliminating or sorry, it's emulating issues which are not present in the network. You just have to emulate it. If one of the issues is actually not presented into network, but with the help of canalizer, you can emulate that issue, send the messages and see how it behaves. So this is the need. If you want to emulate the issue, you need to have the database files. This all points triggers the need for derivation of the CAN database file. Now let's see what are the different elements which are very important when you define the CAN database file or when you create the CAN database file, CAN DBC file. Out of them are the messages, signals, and value description. These are very important and so required actually. So, so what is CAN message actually? When I say CAN message is a broadcast data from the transmitter to the other node on the bus and also broadcast by a transmitter to the request data from a specific node. If you remember my one knowledge session, which was taken on the fundamentals of the CAN, where I talked on the data frame and the remote frame. So when it comes to broadcast by a transmitter to request data, that's the remote frame basically. In simple, it is a frame which contains the unique ID, runs with a defined periodicity, and contains all the signals representing that frame. So that is the message basically. And what is a CAN signal? It is an individual piece of data contained within the CAN frame data field. So signals are representation actually inside the data field of the CAN message. And what is the value description or the value table? So value description let you define your value descriptions for a specific signal. So It let you assign a state description to the physical decimal value of each state of a signal. Very important and very interesting, this value description. So when I say these are the important elements, when you start defining or deriving the CAN database file, my approach is, or my suggestion to you, strong recommendation to you is start from bottom to up. Initially, you create the value descriptions, then you create the signal, then you create the messages, and then you create the node. And accordingly, you have to map. You have to map your value description to the signal. You have to map your signals to the messages, and you have to map your messages to the ECU or the network node. So this is very important. Now, message is clear, signal is clear, value description. In very short description, just imagine you have a signal, and that signal is ignition stage or any drive state. In the ignition state, you can say either the ignition is off or on, right? So imagine it's a signal only. It will either give you on or off value. But in a single signal, if you want to define the different states like off, on, or disable or error, that's possible with the help of this value description. And that's what the value description is required. If you don't want to work on the value description, you can directly start creating the signal messages, and then you can assign that messages to a specific node. These are the elements which we are going to work when you create the CAN database file. But before jumping, I covered that what is the need of the CAN database file. That's extracting the physical value from the raw frame. That's what I defined, I explained earlier. So if you have a DBC that contains decoding rule for a CAN ID, you can extract parameters and signals from the data bytes. So each CAN message is described by a CAN ID, name, length, data field, which contains all the number of signals. So ideally, considering the 8 byte of the data field or length of the data field, you can send 64 bits of the signals in a CAN frame, in a single frame. But ideally, that's not possible because each signals may need multiples of the bits to represent. Best example of the electric machine speed. It may range from the 0 RPM to the 5000 RPM. So that's not possible to create the 64 signals in a single CAN frame. So for each signal, the DBC specifies the detail required to decode the data. So just consider the raw frame here, and then you will understand how you can extract the physical value from that raw frame. To understand why DBC needed and how it works, let's look at how to extract the signal. Just an example of the motor speed from a CAN frame, which we are looking just now. So this is the frame we are looking. I have defined this is an identifier for my message. This is a data length code. It's a 8 byte information I'm sending. First byte, second byte, and up to the 8 byte. This is the value. So imagine without the database file, when you look into your canalizer tool, you can just see this identifier and you can see this raw value. You cannot understand what this 0 means, what this FF means, what is this A010. So everything here, it comes to the database file. You need to create the database file. But creating the database file, the base is a CAN specification document, and that comes from the supplier. Supplier ideally provides you the CAN specification document, or internally your developer or software development team or the CAN protocol developer, they define the CAN specification sheet. What that CAN specification is, which defines what is the identifier for the message, what information it should carry in terms of the signal. If we say the signal, what is the length of the signal, what is the start bit of that signal, what is the periodicity of this message with this identifier, everything is defined inside the CAN specification. So we have just assumed that this is the raw CAN frame, and it's difficult to extract this. So in this example, I wanted to tell you that this message is basically an electric machine drive status message, and it gives you the value on the motor speed. That motor speed value is 1064. But looking at this raw frame, it's very difficult where it's 1064. If I convert this hex to decimal, still you are not able to decode this value. So here you need a database file basically. So in this example, this uh, this A010, that means somewhere here the signal is defined. So in this example, the start bit for the motor speed signal is defined in the CAN specification is at 24 and the length is 16. So it is already defined. So if I say 24, that means this, if I consider this byte, its start bit is a 0 ending on 7. Byte 2 start bit is 8. Here the start bit is 16 and here is a 24, right? So here my message is starting. And what I said in CAN specification, the length was defined as 16 bit. That means definitely I need to consider these 2 bytes. That's what I have assumed this age. I have not assumed, I have taken this A0 and 10 from starting bit of 24. It's a 2 byte information. That's a 16 bit. But you see this value actually we have to consider this A010 for the calculation. So motor speed is a little Indian. Again, CAN specification defines while defining the signal. Either it's a little Indian or a big Indian. When I say the little Indian, I need to restore uh, its a byte order. So motor speed is a little Indian, which you can define even in the database file, and therefore need to reorder the byte sequence from A010 to the 10A0. So that's what I have done here. What I have done from this is how it is represented here in the raw frame. And I got to know that from the CAN specification, it's a little Indian, so I have reordered it. Now, just the last step is just how to convert this value directly to the decimal. So from the hexadecimal string, you have to convert this value to the decimal. What we have done, you just need to know which signal you want to extract from the raw frame to the physical value. I know my signal, that's a motor speed. I know it's a start bit. So if you know the start, let's say its start bit is a different. It's not a 24 bit. It's somewhere around 16 or something. So accordingly, you have to take that data. And if it's a 2 byte, then definitely if it's a little Indian, then you need to reorder the bytes, then directly convert that value to the hexa uh, decimal to the decimal. So hexadecimal string is converted to the decimal now. But still we have not finished because the next step is comes like this is the standard formula for converting the raw from the raw value to the physical value. And for every signal, all signal which are defined under the CAN specification, this formula is applicable. The developers, the designers, as well as the suppliers, they define the scale and the offset for each signal. So here in CAN specification, this is my raw value. What I have to do to extract the physical value of the motor speed, I have to multiply it with the scale and I have to add that multiplication with the offset value. So I know from my data specification, the offset is 0.20, offset is a 0 and the scale is 0.25. Where it is defined? It is defined in the CAN specification. You should know that. So until and unless you should have that document, you cannot create the database file. So we are assuming that you have everything, and then what we have just put that value and we duplicate this value. Finally, this 1064 is derived. So that's what earlier, as I said, this EMDS, that's the electric machine drive status, is having the signal, and that's the name of the signal is motor speed, and the value is 1064, and the unit is RPM. So everything is visible once you have database file, and everything you can define when you create the signal in a database file. You can define the unit, you can change the scale, offset, byte order, Motorola, Intel. So by default, Intel is a little Indian and Motorola is a big Indian. So Intel is by default byte orders comes when you start creating the database file. So this is how you can extract a physical value from the raw frame. Now let's see how the signal layout. So we are jumping towards now to the practical session. Before jumping to the practical session, we should know how the layout looks for the signal. So this is how it looks. When you start creating the signal, it asks for the name, length, byte order. As I said, Intel is a little Indian. If you click on this, it will show you the Motorola option as well. It asks for the value type. Either you need a signed, unsigned. That way you can drag and drop the value table. You have to define the scale. That's what I said. Factor is a scale, offset is offset, minimum and maximum value. And if you have created the value table, you have to assign here. So this is the layout for the signal. And it contains the name, message, start bit, length, byte order, value type, offset, minimum, maximum value, unit, everything, including the SPA and the signal type, and the signal broadcasting is required, yes or no, everything is there. So this is how the signal layout looks. Now jumping to the main window. This is how the main window looks. If you have added the database file, this is how your messages will look. If you drop down the message, you can see the different signals as well. So this is the main window. Now we are jumping to the live example. What we will do here, we will add the value table initially. Then we will create one signal. I will create the multiple signals, but I'll show you the creating the two signals. Then we will create a message. And then with the help of this signal and message, we will assign it to the node. And then finally, we'll run that and we'll see how you are changing the value attributes or the value description, how it changes live into the network. So let's now jump to creating the database file. So till now I have covered everything, that introduction. Then I covered how you can convert the raw frame to the physical, importance of all the elements required to create the database file, the need of the this scan database files, everything. So let's jump to the live demo now. So when you open the CANdb editor, this is how it looks. You need a vector CANdb editor. What you have to do is just have to go here and create a database file. Just follow my steps. If you are missing somewhere, pause the video and start repeating. Repeat the video and start follow my steps only. Different templates are available here. You can go for the CAN template or CAN FD or J1N39. Let's start with the J1N39 template. So I'll just hit OK. It will ask, put the name of the file. So you have to, let's say, I will say motor ECU. This is what I want my database file name. I will hit save. Now you see here inside the network, what is the name of my network? It's a motor ECU. Ideally, for the ECU, I should give the name of the motor ECU, but that's okay. Yeah, that's fine. So what is it? It shows you. It shows you ECU. It shows you nodes. It shows you the messages. It shows you the signal. If you remember my theory, I asked you initially create the value description. So we will create the value description. Where you can create, you have to come here, value table. Hit on that, right click, new. Okay. So once you hit the new, here it come. So let's give the name up. Let's say drive state. I'll say the drive state. Okay. And come here and I'll say add. If I say 0, drive is disabled. I will say drive is disabled. Okay. Drive is disabled. So just imagine I try to link with your application. If you are working on ignition on and off state, you have to write the description accordingly. I need another state. I can put 1. That's drive enabled, right? Drive is enabled. Or error, I can take even 3, or 2 is my third state I can take. That's error state. Okay. So this is up to you. What I will do, apply. Okay. This is done. I will minimize this. Let's come here. Now create the signal. So we'll create the two signals. One is I will create, let's create machine speed or motor speed. Okay. Length is 16-bit. I need a 16-bit. I'll keep it Intel. That's a little Indian. I said if I say Motorola, they will go the big Indian. So signed, yeah, for the speed, I don't think so we need it signed, but it's okay. Let it be. Then the factor, I know the factor. So my factor is 0.25. So I'll keep it 25. Offset is 0. And maximum I'll go to the 5,000 or something, or let's say 4,000 RPM, or it up to you. That's 5,000. And here it asks for the value table. We have created the value table, but this is not related to the motor speed, right? So I will not assign that value table here. Just hit apply. Okay. I created one signal. I'll add another signal. To create the signal, you have to come again to the create signal, hover your mouse, right click, new. Here we will create the drive state. Let's say machine drive state is the name. Length 8 bits are okay. What is the start bit? Or let it be Intel, signed, factor, and so length is 8. That's okay. Factor upset 0, minimum and maximum value, I would say it's a 3. Okay, here I will assign this drive state. Then I will apply it. Okay, okay. So here you see, here it shows everything, right? Length and everything, your offset, initial value and everything. Okay, so if I double click on this, it shows you message, attributes and everything. We have not defined it, but yeah, okay. So we have created the two signals, right? One is this and machine drive state, and another is motor speed. Okay, let's create the message now. So then I'll create the message. I'll give the name of the message is MC info. Let's say I want to take the motor controller information. So let's say motor controller unit information. Okay, and then come here and add the signal. You have already defined the signal. Select the signal. I'll select both signal. Okay. Now it will ask you to start. Where you want to start? You have to be careful. Okay. So then I'll hit apply. Okay. Coming here, you see here. Now it is reflected. Why earlier it was not reflected? The reason we had not defined the message. So the signal is only defined, but in a message where it should start. So after you define the message and assign to it, then it asks you what's the start bit. So for drive state, the start bit is 8. Okay, sorry, 0. That means I'm starting from the first position, first byte, and the length is 8. For the motor speed, mine is earlier it was start bit was 24. So let's start with the 24. Okay. Okay. Done. So let me. Okay. So it is clear now. So now we'll go for creating nodes. So this is done. This is done. So if you see here inside this message, this signals are mapped. Now coming to this message, I wanted to change the identifier also. I know my identifier, it's 0C F002B2. This is what we earlier seen at the frame. And here I want to say the DLC is 8. Okay, apply. Okay. Now the error has gone because earlier we have not defined this length, so it was confused over there where we should. I mean, DLC was 4 and we were starting with the 24. It was going beyond that limit. So that's what it was. That yellow mark was here. Now messages are created. Up till now, if you are following me, everything is done. This is done about creating the database file. But beyond this, if you are working with the multiple issues, then you need to create the nodes. And if you want to send a specific message, just want to receive the specific message, that is possible to create inside the nodes that transmit and receive. So till now, your job is finished. You have created the database file, and this database file will work for transmitting the message as well as receiving the messages. But let's go for just slightly higher. So I will create here one node and I will say, this is my motor controller. Okay, so this is my node. And what is the address? So source address is from the here. So B2, I would say it's my B2. B2 is a source address. And here it asks, do you want to map the transmitted signal? Do you want to transmit specific signal? Yeah, I want to transmit. Then if you want to map receive signals, yeah, you have to receive the signal. So accordingly, you can map your uh, signal. Let's say I want to receive this motor speed or something. So I can do this way, apply, okay. So as soon as I do that, if you see here inside the receive, this message is populated, right? So this is done. So just hit on this and save this. Remember the name of the database file. That's very important, motor ECU. Now let's use the database file and see how it works. Very simple, very simple. What you have to do, initially you have to create the drive description or the drive, your value table, value descriptions. Then you create the signal, map your value description to the signal. As I said earlier, follow the hierarchy, then map the signal to the message, create the message, then map that, define everything, identifier and everything, start beat, then stop beat, as well as um, your length, everything, and create the node. And accordingly, after creating the node, you see here inside this, I can. Okay, you see here, my motor controller is already populated, right? So this is how it is done. Now let's save it and let's go to the canalizer and try to send and receive the message, and let's see how it works. Okay. Okay, so here I'm live. What I'll do, I'll just right click on the hotspot and I'll hit on the interactive generator. You can go for the programming node also, and you can transmit with the help of your database file. And before jumping there, very important that I have covered the basic on this canalizer, how it works. So I'm not gonna talk here again. What is this hotspot? What is this analysis windows and all? What is the use for that? And what is this PC board and everything? But I have covered everything. I request to everyone, please go back, revisit my previous session on the canalizer basics, and then jump to this video. So it would be helpful for you. So before starting to send this created messages from the database file, you need to assign the database file. What I'll do, I will assign the database file on my uh, this channel 2 instead of working on the channel 1. I want to work on the channel 2. So let's work on the channel 2. So here I created the database file and I am assigning that database file. So here I created, right, the motor issue. I'll hit OK. You can assign here also, but I'm gonna work on only on the CAN2. That's what I have assigned into the CAN2. It is very important. On which channel you want to work on, there you have to assign your database file. I've seen many of my colleagues, many of my friends ask me, I have assigned the database file, but still I'm not getting my messages, or I'm not able to trace my signals into the trace window. The reason is you works on the CAN1, you assign the database file to the CAN2, or you works on the CAN2 and you assign the database file to the CAN1. So that's the biggest mistake you do. So make sure that wherever you have assigned your database file, you work on that channel only. Work means when I come here and add my interactive generator block, hit on this, it will ask me the either you want to send the raw frame. No, I don't want to send the raw frame. I have a database file now. I'll click on selection, come here under frame. This this is the message we created with this identifier and with this source address, everything. I will hit OK. Now you see here, we created this value table, right? So this is the beauty of creating the value description. With the help of this, you can enable, disable, you can throw it into the error. That way you can do that. And accordingly, it change the value and a respective issue response. Instead of making it manual, I want to make it periodic. And here I want to send it on CAN2. This is important. If you are sending on the CAN1, then definitely you will go into the error, not error, but you will not able to decode your message on the proper channel. So DLC is 8 and everything is done there. Now what I'll do, I'll just hit run here. I'll come here and I will hit run here. So everything is done. Let's go to the measurement setup, trace window, and here is my message, right? And here is the value. Okay, so let's send some value. So what I want to send some value. I want to send the motor speed. What motor speed you want to send? Let's say I want to send 1064. Just hit OK. Why I send this 1064? I would request you to pause here and go back just 10-15 minutes earlier. I explained one frame. There I was talking about the decoding of the raw frame. And here, if you see A010 is bits if you set this speed. If you set this 0, you see that is changing. Here 00 is there. And if I set the value 1064, according to my physical value, according to my scaling and offset, this is coming there. So A010 is there, but it's a little Indian Intel byte order I used. That's what we need to rearrange the bytes. And that's what it is 10A0. But if I don't have the database file, I may not able to decode this frame. You can see the raw frame as like this. These are the raw frames. You're not able to see what is this changing. What is the meaning of that? Because you don't have the database file for that. So that's the beauty. You need to have the database file. Let's stop here and I will remove the database file. Okay. Remove database file. Okay. Okay. It is saying you have configured into CAN interactive generator block and you want to remove. So it may end up with the error. So if I run this and if I come here in trace window, nothing will be found. I know the identifier. My identifier is source address is B2. Let's find the message B2. Somewhere here it would be there, right? Because we are sending that message. So let's check where you can find identifier B2. Let's check, is it we are sending? Yeah, we are not, because we are not trying with sending the raw frame. We pulled it from the database file. That's what the error is here, and it is not showing the frame here. So let's stop. And then if you want to see a raw frame here, you need to add the raw frame here instead of going for pulling from the database file. Again, I'll add the database file here, which database file we created earlier. Then let's go here, check either it is, yeah, everything is done. Then let's run and let's look here. Yeah, now you're here. Now let's check for this value description. If I change 1, you see here, machine drive state is 1, right? If I change 2 here, I can see the machine state is 2. So that's the beauty with this value description. You can define the value description and you can change the states accordingly the value, because we defined that start bit is 0. That's what, and we length was 8-bit. That's what this field is getting changed. This byte is getting changed where my cursor is hovering. So if I go here and 0, see here, it is changing, right? It is coming 0 here. If I change some different speed, let's say 4000 RPM, something. So accordingly, you will get the 4000, right? So everything is possible. And somewhere in the database file, we have not written down the unit. That's what it is not showing here. Let's look for that also. If you define the more inside the motor speed, need to define inside the signal unit. Let's say RPM. Okay, apply. Okay, save it. That's very important. And my suggestion is remove. Okay, okay, and then add. So double check. Then come to measurement setup, and you see a RPM is reflected. We are sending the 4000 RPM. That's what it is showing there. Let me change the 1000 RPM. It will show you the 1000 RPM. Yeah, it is showing the 1000 RPM. So that's all I guess I have for today's session. And I would like to know always what was the valuable for you inside this video and what was your most valuable takeaway from this video. So tell me in the comments below for the chance to be my next viewer of the week. And I'll see you in the next one. Thank you for your time and please like, share and subscribe. Thank you. Bye bye.